Your house is bleeding money right now. While you sleep, while you work, while you sit in the very room you are reading this, a machine bolted to your wall or buried in your basement is consuming nearly 1/5 of every electron your home draws from the grid, costing American homeowners a combined $29 billion every single year, according to the U.S. Department of Energy. And the cruelest part? You were never supposed to need it. There is a design principle, a dirt-cheap, zero-electricity, physics-driven system that builders in the 1920s understood intuitively, that ancient civilizations mastered 3,000 years before the first kilowatt was ever sold, and that an entire industry has spent decades quietly burying under concrete slabs and sealed double-pane glass. It costs nothing to operate. Its fuel cannot be metered. You cannot be billed for it by the month, and you can restore it in a single weekend with $10 of hardware from any home improvement store. It is called the wind tunnel effect. Some know it as cross-ventilation. Others call it the stack effect. Engineers call it passive ventilative cooling. Your great-grandparents just called it building a house correctly. Welcome to the Forbidden Vault. Subscribe if this knowledge matters to you. This is not folk wisdom. This is not a home improvement trick. This is a technology with a documented lineage stretching back to 1300 BCE. Egyptian artwork found near Luxor, dating to around 1300 BCE, depicts early wind tower designs atop Pharaoh Nebamun's royal residence. These structures, called malkaf, were precisely engineered scoops positioned to face the prevailing breeze, drive cool air down through the building's interior, and expel the hot, stale air from a second high opening on the opposite side. The pharaoh was not living in discomfort. He was living in a thermodynamic machine. In Iran, the Persian badgir, literally wind catcher, was used in Achaemenid architecture, and its effectiveness led to its routine use as a refrigerating device. Many traditional water reservoirs, capable of storing water at near-freezing temperatures during summer months, were built with wind catchers. Near-freezing water in a desert without electricity. The mechanism is not magic, it is physics. Wind towers can reduce indoor temperatures by 14 to 22 degrees Fahrenheit and provide up to 30 air changes per hour without any electrical input. Now move forward to the American continent. American Victorian architecture in the southern United States evolved deliberately to address warm summer climates. Ceilings became taller, often 14 feet or more, serving not only as a status symbol, but as a means to direct heat upwards. Tall, double-hung sash windows with outside shutters could be opened at the top and bottom, allowing air to circulate via a chimney effect. This was not accidental. These builders were applying the same stack ventilation principle the Persians had refined for 2,000 years. And the 1920s craftsman bungalow, the most ubiquitous house style of its era, was a masterwork of passive thermal design. The craftsman style features large front porches, a low-pitched gabled roof, wide eaves, and exposed beams. Craftsman houses historically included sleeping porches that provided a cool place on hot nights. The wide eaves blocked high summer sun. The deep front porch shaded the interior walls. The room layout was narrow and rectangular, specifically engineered to allow cross-ventilation from one wall to the opposite. Before electric fans and air conditioners became the norm, a sleeping porch provided a suitable sleeping environment in both summer and winter through the use of wire screens, casement windows, and correct orientation. The science behind it is straightforward. Cross-ventilation is powered by wind and requires no energy input. Windows or vents positioned on opposite sides of the room allow passive breezes a pathway through the structure, which circulate the air and provide passive cooling. The pressure differential between the windward face and the leeward face of a building creates a flow. Air rushing in one side, heat pulled out the other, in a continuous loop that costs exactly nothing to sustain. Almost all historic buildings were ventilated naturally. The technique was generally abandoned in larger U.S. buildings during the late 20th century as the use of air conditioning became more widespread. Read that again. It was abandoned, not superseded, not proven obsolete, abandoned. Stay exactly where you are, because what comes next is the part they specifically do not want you to understand. The why. The structural reason this knowledge disappeared from every architecture curriculum, every building code consultation, every contractor conversation in America. This next section is the most important thing you will hear today. Here is the problem with wind. You cannot patent it. You cannot meter it. You cannot charge $265 a year, the U.S. Energy Information Administration's own national average for residential air conditioning, for something that flows freely through a correctly placed window. Air conditioning equipment is used in 87% 9% of homes in the United States, and home air conditioning costs averaged $265 in 2015, or 12% of total home energy expenditures. In the hottest regions of the country, the humid Southeast, air conditioning made up 27% of home energy expenditures. The U.S. HVAC industry reached a market share of more than $30 billion in 2023. Nearly 90% of U.S. households used air conditioning as of 2020, up from 77% in 2001. And the U.S. HVAC systems market is projected to reach over $54 billion by 2033, growing at nearly 7% per year. This is not a comfort industry. It is a dependency industry. Its product is not cool air. Its product is a monthly electricity bill that never ends. Consider what happened to post-war American housing. Natural ventilation was generally abandoned in larger U.S. buildings during the late 20th century as the use of air conditioning became more widespread. The suburb exploded after World War II. Builders discovered they could shrink ceilings, seal windows, orient homes toward the street rather than the breeze, remove the deep porch, and cut construction costs dramatically. Because the discomfort that would follow could be patched with a compressor and a refrigerant loop. The builder's cost went down. The homeowner's monthly cost went up forever. In 2020, electricity consumption for air conditioning accounted for about 19%, 254 billion kilowatt hours of electricity consumption in U.S. homes. The United States, with 4% of the world's population, consumes more energy for residential air conditioning than the entire continent of Africa uses for all purposes. This is not a climate problem. It is an architecture problem, one that was deliberately created and is being deliberately maintained. If you have read this far, you already understand something that the majority of American homeowners do not, that the solution was built into every house constructed before the compressor was invented, and it can be built back in. Here is how you restore the wind tunnel in any home this weekend. Step 1. Map your prevailing wind direction. Every region has a dominant summer breeze direction. In most of the continental United States, summer winds arrive predominantly from the south or southwest. You can find your specific prevailing wind data through the National Weather Service or any free windrose tool online. This is your inlet side. Step 2. Identify your inlet and outlet windows. If windows on both sides of a building are opened, the overpressure on the side facing the wind and the low pressure on the sheltered side will make a current of air through the room from the uncovered side toward the sheltered side. Your inlet window faces the prevailing wind. Your outlet window faces away. Open the inlet smaller, the outlet larger. It is better to have smaller windows on the windward side than on the leeward side. This strategy increases the velocity of the wind inside the room. A narrower inlet, like the nozzle of a hose, accelerates the air. Step 3. Clear the interior path. Walk from your inlet window to your outlet window. Every closed interior door, every piece of furniture across the line of flow, every wall with no transom vent is a dam in your wind tunnel. Consider installing a louver or awning window above internal doors to let breezes pass through the building while maintaining privacy and security. These louver vents cost between $8 and $15 at any hardware store and can be installed above an interior door in under 30 minutes with a jigsaw and a screwdriver. Step 4. Add the stack assist. Even when there is no wind, heat will still move. Buoyancy-driven ventilation uses the density of air to promote air movement. As air enters your home, it heats up and becomes less dense than the cooler air on the exterior. As a result, the warmer air rises. When that hot air rises and has a place to exit the building at a high level, like a clearstory window or roof vent, it naturally pulls cool air from lower-level openings. Open your highest window on the outlet side. Even 2 inches of gap at the top of a leeward window creates a chimney effect that works in still air. Step 5. Use the night. Whole-of-house fans can draw cool night air across beds near open windows, provided doors are left open for circulation. On still nights, this can be more effective than air conditioning for nighttime sleeping comfort. The cooler night air pulled through your cleared path and into the thermal mass of the walls and floor becomes the battery that keeps the interior cool the following morning. A retired builder in western Tennessee named Dale Whitfield tried this system on a 1970s ranch house he had purchased. The home had no porch, standard 8-foot ceilings, and windows poorly placed for crossflow. He added 2 $12 louver vents above his hallway door, repositioned 2 pieces of furniture, and began opening his leeward upstairs window at night. His first electricity bill after making those changes dropped by $74 over the prior summer month, without touching the thermostat setting.